So we want to find the z-score corresponding to the area percentile. The area is straightforward, but when we say percentile, we have to say which percentile and find the corresponding area. So since we're talking about z-scores, it's always 0 and 1. The mean is 0, standard deviation is 1. And cumulative area is 0.6736 below a certain z-score. Should that score be here?
No.
There.
Yes.
No.
Well, somewhere over there.
Somewhere over there. So 50% is right in the middle. So this is arbitrary. And that is the z value we are trying to find. So the area below that value is 0.6736. So this is the inverse process of finding the cumulative probability, because the probability is given and we are trying to find the corresponding percentile. So in your calculator, this is inverse norm. And the calculator always takes the area below. So area below the percentile is 0.6736. In this case, the mean is 0, standard deviation is 1, so 0, 1. Even before we start the problem, could the answer be negative 4.2?
No.
How about 4.2?
No.
How about 2?
No.
1? 0.5?
Yes, sir.
Maybe. So plug that in and what do we get?
Yes. 0.4499.
Good. Yes.
In my calculator, it says like tail left, center, and right.
Yeah.
I mean, left and right is pretty self-explanatory, but what does it mean when it's center?
The area between two critical values. So from the center, you go a certain amount to the left, a certain amount to the right, and you specify the area to find the two critical values. So I'm not sure if we have a problem like that in the text, but if we did, we can do that problem. So the newer versions of the calculator, they do give you an option of left and right. In the sense, if you select left, it's equivalent to that syntax. So it's going to look at the area below. And if you choose right, it is going to look at the area above. Let's say if we have problems where we have area above. So if not, just set it at left. The second problem, the percentile is given. We're trying to find P88. So the area below whatever z value that you pick has to be 88 or 88%. So could that value be negative?
No.
Could it be over there?
No. It needs to be
There,
No.
there,
No.
maybe?
Yeah,
Well, maybe.
Yeah.
And what is that area?
0.88.
And where do we get that 0.88 from?
Divide the percentile by 100.
So whatever we are finding right here is the 88th percentile. The process is the same. You use inverse norm. area to the left or below, followed by the mean and the standard deviation, and what do we get?
1.17498.
Or 1.175.
Lastly, we have P75. Could it be negative?
No.
So the area below the percentile is 0.75. Where are we getting that 0.75? 75th percentile, 0.75. So the area below is 0.75. Percentile 75. It's my cat moving around the house.
What?
So
That needs an explanation.
P75 would correspond to which quartile?
The third.
The third quartile.
I would be scared if I were that cat.
So the area below is 0.75, so in the storm 0.75, 0 and 1. We know the answer has to be bigger than 0, so what do we get?
0.6745.
So another way to be sure of the answer that you're looking for is this one diagram or picture from the empirical form. So 0, 1 standard deviation, 2, 3. Yes. On this side, we have -1, -2, -3. And each of those will correspond to a percentile. So this is P50. Do we remember what that is?
What is what?
Percentile.
Wasn't that like
Empirical rules.
68.
60.8.
No, 68.
No.
60.5.
It's an 80 something.
60.5.
P84. What about that value? It's P97.5. P99.85. On this side,
Isn't it 825?
No.
You sure?
what's the this value is P16. P2.5 and P.1. Right? So if you go back and look at each of the problems, so P88, that lies between 84 and 97.5. So whatever answer that you're looking for has to lie between 1 and 2. Got it?
Yes.
Over here, I'm looking for P75. So whatever answer that I'm looking for has to lie between 0 and 1. Does it?
Yeah.
Good. Yes.
So, let's say that you were asking to find like the area or the z-score to like, wouldn't you just do 1 minus whatever your calculator says?
Yeah, we're about to do that.
Okay.
If you do it with the center, you should get the center point.
So the first one here is straightforward. We're trying to find the percentile, or excuse me, the percentile here. The area is given to us, so we can directly put it in the calculator. So in this norm, the area below is 0.3520. the mean is 0, standard deviation is 1. So anytime the problem states standard normal, or if it just gives you mean 0, standard deviation 1, then we're talking about a standard normal distribution without a specific standard deviation. So plug that in, what do you get?
Negative 0.3799.
I mean, obviously it has to be below 0. This one has to be below 0. I mean, it is below 0, so the answer has to be negative. By some odd chance, you just directly put invnorm 0.7190, 0 and 1, you will get a positive answer. So you've got to stop and think for a second. Well, if that's the case, how could you get a positive answer, right? So something's going on. If you have that newer fancy version of calculator, you can choose left, right, or center. So in this case, you would choose right. But if you have the older versions of the calculator, mind you that the first argument is always the area below. In this problem, the area above is given. So if you have the area above, how do you find the area below?
Subtract.
You do 1 minus the area.
I didn't know to do that, honestly. Wow.
And what do we get?
Negative 0.5799.
That's right. Now on to the case of the center. So the newer fancier version of the calculators, gives you an option as to whether to choose the center or not. If you have that calculator, the area in the middle is 0.95, 0.475 plus 0.475, 0.95. I walked around, I found some answers that was minus 0.06 or something like that. It can't be that value because it's very close to 0. And you have a whole lot of area here, so the answer has to be slightly larger. So you put 0.95, choose center, it's going to give you the answer.
1.96.
1.96.
Negative
yes.
and positive.
But if you have the older version, fret not, what area do we have in the middle?
0.95.
0.95, so 47.5% plus 47.5%, that is 95% or 0.95. If 95% is accounted for in the middle, what amount is not accounted for?
0.5. 0.05.
5%, right? Or 0.05. But normal distribution is symmetric, so we've got to divide it by 2. Agreed? So I'm just going to do this side. So the area is 5% divided by 2, 2.5%. Yes?
Are you gonna ever give us a question like this on a test?
Probably.
You know.
So the area below is 0.025. So I'm not using the right hand side at all. There is a reason for that. So the area below is 0.025, 0.1, and what do we get?
1.96.
From below 0.
Sorry.
Negative 1.96.
So because of symmetry, if this value is negative 1.96, that has to be positive 1.96. So if you have one of the older versions of the calculator, always try to find the area to the left of the number. You can always use symmetry to get the other number by multiplying with -1. Yes.
Are we gonna have a situation in which it will have like 0.475 on one side and 0.645 on the other side?
Great question. So if this is not balanced in the sense, say you have 0.5 on one side, 0.3 on the other side, that is actually trickier. So you can't simply put 0.8 and center in the problem. You get the wrong answer.
So we'd have to do the 1 minus 0.3
Exactly.
situation, okay.
Yes. So this is only applicable in the sense you would use the center option in your calculator if the areas are the same.
Okay.
Last case, now that I've given you this, I believe that area was how much, 2.5?
0.05.
Or 0.05.
So the area below is 5%, which is 0.05.
Is that total or is that just on one side? Like 5.
What did the problem say?
I don't.
It was 5% and 5%. So 0.05 mean is 0, standard deviation 1, and what do we get? 1.64.
Negative 1.6448 or 9.
If this is negative 1.645, what is that?
Positive 1.6.
Positive 1.645.
For that time.
So the random variable X is the per capita energy consumption in kilowatts per hour in Venezuela. The mean is given 2,277 kilowatts per hour. And standard deviation is 584.2. It is normally distributed, given in the problem. So if you can't do this directly, what should you do?
Draw it,
Draw it out.
like always. What occurred?
And
Redo it.
mean is 2,277. And we want to find P5, correct? So P5 simply means 5% is below whatever number that you're about to take. So even before you start the problem, could the answer be 1?
No.
Could it be 10?
No.
Could it be negative 24?
No.
Could it be 2,000?
No.
Could it be 1,000 something?
Yes.
Yes.
Maybe, right? Below 2,277.
1,000 something is the answer.
Yeah.
So you can put the area below the mean, standard deviation. The mean is given 2,277. Standard deviation is 584.2. And what do we get?
1,000 something.
1,000 something. What is that something?
1,216.08.
0.7.
1,300.
316.
Point.
316.
0.08.
There you go. You keep rounding, creating around.
So now we've got to find P17. Do you expect this answer to be bigger than the previous one?
Yes. Yes.
Naturally, right? Because P5 is over here, which means P17 somewhere over there. Actually, a bit more on the right. It has to go over there. Right?
Yes. That's a little too far to the right.
Yeah, that's not right,
Good enough. So the area below P17 is 17%. So 0.17 mean followed by standard deviation. And what do we
man.
get?
Looks like it on the graph.
So you get 1719.
1719.
Exactly.
No, 58.
0.
In the last case, we have Q3. Which percentile does Q3 correspond to?
75.
It has to be bigger than this because this is P50. So P75, somewhere over there, should be a bit closer to the center. Regardless. What is the area below P75?
$2,670.
That's the area below P75.
0.75.
0.75.
You're close enough.
The area below is 0.75, mean, and standard deviation. And what do we get? Basically an answer bigger than 2,277.
Go again.
Go for it.
I don't know, error knowledge.
2671.04.
0.0369160.
04.
So this is what I recommend. In a problem like this, add 1, 2, 3 standard deviations, subtract 1, 2, 3 standard deviations from the mean, and draw the other line that I drew in terms of the percentiles. So you look at the problem, you can easily guess as to what the answer is going to be. So process of elimination, even if you get stuck, you can actually use process of elimination to get to the correct answer. Does that make sense?
Yes. Well, I do it.
I put 0.955.
So bags of baby carrots, X would be the weight of baby carrot bags, and mu is 32 ounces, standard deviation is 0.36, and the weights are normally distributed. And the problem states if the bags are in the upper 4.5%, they need repackaging. The question is, what is the most bag of baby carrots weigh and not need to be repackaged? Now, the problem doesn't care about underpackaging, right? Less than 32 is perfectly fine. Just can't be more than 32, which doesn't make sense. So even before you start the problem, the answer cannot go below 32, right? The average is about 32, and you want to seek or look for an answer that's bigger. So the top 4.5% would mean anything above whatever number that might be. .5%, if you convert it to a probability, it is 0.045. Inverse norm wants the area below, so if the area above is 0.045, what is the area below? 0.955, and how did we get that?
You just subtract 100 or 1.
And what is the answer?
You get 32.61.
6103.
Yeah, thank you.
03.
Good enough. Are we clear?